Show you a little bit, just a tiny bit about stats models. Um, First, here's their website, and zoom in a little. It's a Python module that gives you statistics functionality. So statistical tests, data exploration, models, etc. It's the sort of thing that R is incredibly strong at, and other programs like Stata and so on. And now you can do that sort of thing in Python. And their kind of first big proud thing that they're pointing out on their website is that you can use this notation when constructing models and doing fitting, which is apparently exactly the same notation as in R, or very similar. And so if you run this code, you'll see lots of information about a model that's been computed. So that's their main website. And then what I did was I took, just to show you something actually working, I took their first tutorial, which is kind of the first thing you should do. Here's some code that loads stats models and some other things that are used in this getting started tutorial. And then we're going to go through this tutorial. Okay. So there's some data set called the Curie data set, which we will load from an 1833 essay on the moral statistics of France. So let's load it and display it. So there's a command, sm is statsmodels. See up here I did import statsmodels.api as sm. And then if you do get R dataset, there's just some huge collection of R datasets. And you can read them not only into R, but into Python via this function. This gives you back something. In this case, it's just a data frame like we've been constructing all week. And I show you the top of it. Here it is. So it's just a lot of data from the old days in France about money, literacy, poverty, etc. Okay, that looks really tiny, sorry. So we select the variables of interest and look at the bottom 5 rows. So there's lots and lots and lots of columns in this data frame. And using that notation, we shrink it down to look at only 5 of the columns. And then we just display some of the rows. So in various places in France, this is comparing, I guess, some count of the number of people who are involved with the lottery to literacy to wealth, etc. I don't know. And then there's a point here that there's a nan value that's missing in some location. And so they just tell you to use drop nan. And then you get something back where all the rows that have missing data are just removed. Okay, and now here's some statistics. So they're talking about what sort of model they're using. I'm not going to try to explain it as I am not a statistician. But to those of you who have taken stats classes, this will hopefully mean a lot to you. So now they use a least squares regression model to fit the data. So the point here is that it's a couple of lines, uses some notation that should make a lot of sense to people who are familiar with statistics. And when you run it, you get as output, let me zoom out a little, this. And this happens very quickly, or instantaneously. You get all these parameters that describe some model, tell you about the data, etc. The point mainly is that there are, if you look in the stats models documentation, let me just kind of click to it, to their table of contents. Where's their documentation? Their documentation is not obvious to me. They have a huge amount of documentation. Maybe it's under support. Nope. Okay, I was just staring at it before. Okay, stats models documentation. But when you look at the table of contents, it's really, really impressive. Okay, so current stable version, which is what's installed. Oh, that's not the doc. Geez. Oh, here it is. Look, so expand all. So you can see they have a large number of statistical models, and it's just, there's a huge amount of work that's gone into this. And they have, like, for all of these, they have all kinds of examples and really good documentation. Okay, and here's an example of drawing a plot using stats models. So it has this module sm.graphics, and then you can plot some sort of scatter plot, and then it shows a line that's supposed to fit that data. Okay, so the point of this isn't to teach you how to do statistics, but tell you that there is a package that you can use from Sage or any Python install if you do pip install statsmodels, which lets you do an enormous amount of stats nicely and combine it with anything else you can do in Python. Okay, that's great. Okay, next, I'm going to zoom in because this is oddly small. Just make it bigger. So next, Scikit-Learn. So this is a machine learning package. And since machine learning is so fun, I could see us maybe doing a bit more of this next week. Here's the website. It'll come up in a second. And let me just zoom in on this part. So Scikit-Learn is a package for machine learning in Python. And it's very open source, extremely sort of straightforward to install and use. And it lets you do machine learning type stuff. So they list various machine learning type things you might do, like classification, clustering, and so on. I'll show you one example today, which is one of their first examples, which involves it's a really, I guess, nice introductory example of machine learning. They have over 1,700 scans of handwritten digits that come from zip codes. And they know what the actual numbers are because somebody looked at them with their eyes. And then they have that data available, and then they use one of the classification methods, as we'll see in a minute, to set up something that predicts which number you're looking at. So you give it a scan of a number, and then it will predict which number it is. So we'll play around with that in just a moment and see what we get. Okay, so here's how you do it. So the module is called Scikit-Learn for Scikit-Learn. Import datasets. So datasets has a whole bunch of, or has some function. This module has a bunch of functions that have some datasets that you can work with, all cleaned up. Digits is one of them. And as I mentioned before, digits it's basically 1,797 handwritten lower resolution numbers. They're pretty low resolution from postal codes. So this digits thing, let's load it. You do digits.tab, you'll see that it has various attributes. And one of them is data, right here, which is an NumPy ND array. And in this case, it's a two-dimensional array. Each row is one of the scanned digits. And to make this a lot more concrete, I have written a little code that will plot one of these rows. Okay, so, just before I show you that, the data that we have is, again, it's a bunch of like 8 by 8 scanned digits. So the resolution's super low. The resolution is literally 8 bits, 8 pixels in each direction. So that's all you have. But that's what these numbers represent. Like the first row, digits.data0, that's 64 numbers. And that represents an 8 by 8. So if I do .reshape, I'm worried with that. That'll mess things up. But yeah, I think I can do .reshape 8, 8. Yeah. So see that? There's some number, either 0, 1, 2, 3, etc. And this is a scan of somebody who wrote that number. And the thing digits target, that tells you what the corresponding number is. So in this case, see what you're looking at right there? That's 0 scanned in. Notice it kind of looks like a 0. The zeros, they're black, and the other numbers are white or something like that. So this is what happens when you write a 0 by hand. That's what it looks like. And then the next one is supposed to look like a 1. So if we do data shape 1, it kind of looks like a 1, right? So we wrote a 1. But it would be better if this plot were an actual plot. So let's look at this. This code right here will use matplotlib matShow command to draw the 8x8 matrix corresponding to one of our scans. So let's take this first one right here, and again, let me reshape it to 8x8. Reshape is something that we'll learn about next week when we learn about NumPy. So here we are. So plot data 0. What that does is it turns that 8x8 array of numbers between 0 and whatever into colors, in this case grayscale of colors, and then draws them. So this is supposed to be a handwritten 0. But again, it's very low resolution. And then if we look at the next one, or actually let's look at 3D9. This is supposed to be a handwritten 3, and there it is. And it does actually look like a 3, right? Okay, and you can just, you can look at any one of these numbers, like 350. The 350th item in our data set was a handwritten 7. That really is hard to tell. Handwritten 6. So some of them are pretty bad. So it's amazing that it could ever work. But scan of an 8, etc. Okay, so. Okay, this is really tiny, so I'll just read it to you. In the case of the digits data set, the task is to predict, given an image, which digit it represents. We're given 1,797 samples of each of the 10 possible classes, the digits 0 through 9, on which we fit an estimator to be able to predict the classes to which unseen samples belong. So there's, of course, a lot of different possible ways to do that. That's, machine learning, it's a huge topic with a huge amount of depth. Here's one example. They're going to use something called support vector machines, which are something I won't get into at all right now. But there's some parameters. Uh-oh, somebody is evaluating stuff. Thank you. People in the audience evaluating stuff. I will switch to my own project because you're changing too much stuff. So I'm just going to switch to my own project where things are not being changed. And let's do this. So these parameters 0.01, 0.001 and 100, they were just sort of obtained in some way that's not explained. And then what you get is, so this doesn't know anything about our data yet. It's just some think of it as a black box that given some data as input, it'll adjust some of its parameters and then try to recognize as or classify as given above. So these parameters, Scikit-Learn has various packages that will let you try to estimate what these parameters should be, and we're not going into that right now. So just consider these like something that somebody worked really hard and figured out that these parameters work really well for handwritten digits. But again, at this point in time, when we type these two lines, we have in no way actually looked, the CLF thing, this Python object CLF doesn't know anything about our actual raw data yet. Okay? So the CLF above, it's a classifier. So it takes as input the row of this NumPy array, and then it gives you back either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And right now we have 1,707, or however many, 1,797 rows of our array. And then for each one, somebody by hand said, this is a 0, this is a 7, etc. And what we're going to do is we're going to teach this particular support vector machine using our data. And we'll do it by training it on all but the very last data point. And then we'll see what it predicts for the last data point. Okay? Just to remind you, so the very last data point would be what we get if we take 179, not 7, but 6, because it starts counting at 0. So here's the last one. That blob there is supposed to be a scan of an 8. So what we're going to do is feed in all of our data except this one, and then see what happens. It's going to train our model. So what this does is it feeds in everything except the last value. Okay, so it very quickly did something and adjusted various parameters as a result. And then that's just the plot I showed you above. And now it's going to try to predict. So clf.predict. And then what you do is you give it, I'm slicing here, but this gives me the last row of the array, of the NumPy array. And it predicts 8, which is correct. It's correct because we do digits dot, remember at the top we had what the correct values are, digits dot target. If you do digits dot target of 1796, whoops, forgot the T. It really is 8. So that's great. So now the exercise for you to do right now is to run the predictor just like this on all 1,797 scanned values to see how many are correct. Okay, so one of them, it does work correctly. Now let's see what happens with the others. It may be that, well, yeah. So just to give you an example, here's how you can do it on 5. Notice you have to do 5, 6. That slices out exactly the row of the NumPy array that corresponds to the scanned image for 5. And you get two things out. Digits.target square brackets 5, that gives you what it should be. And then clf.predict gives you what it predicts as a one by one array. So what you need to do is write a little tiny bit of Python code, kind of like this, that says, do you see what I mean? Like you want to test it for n, so you do n plus 1, and that sort of thing. So just to give you even more hints, that's going to return true if it was correct for that value of n. The fact it's always returning true may suggest that it always gets it right, and that might be because we've told it about everything. But after you've written a little loop that will go through and test this and count up how often it's true, you can recreate CLF from scratch at the very top, right? Way up here, just re-evaluate it. Just delete it and re-evaluate it. And then you can try retraining. And instead of retraining on all of the data, which is what I did here, train it with far less of the data. Like maybe give it just the first few hundred scanned numbers and see what you get. And then do the same thing again. Okay, does that make sense? If you're confused, feel free to ask any questions. I'm going to walk around and answer questions while you try out Scikit-Learn machine learning. Okay. So I'll leave that up because it's kind of relevant. And let me just emphasize, after you do this, delete or completely recreate CLF, but trained on way less data. Because it's kind of boring when it knows all the data. Sort of cheating. Okay. thing, if you're working in the shared project, so like in the upper right, you see that there's like 10 people with the same worksheet open. It could be potentially confusing because you're both working on the same worksheets. So you're referring, you could, just so you know. So you're working in the shared project, so it could, instead of your own, so it could possibly throw things off. Just because like the guy behind you, for example, is editing the same worksheet. Just so you know, but you can copy. Just be careful about that. Any questions? Oh, where you put 6, but I put 7. And then where you put I, put 0. I should probably put that in the shared version.
So I'm finding that like counts and stuff. I think I'm just like missing something.
All cells.
Control A plus. So you're doing count plus equals count here. The count is 0, and you're just adding 0 each time. So change it to a 1. And here you're doing this doesn't.
Okay, I don't see that.
Right,
right.
index
Okay. Okay.
Okay.
Okay. I.
No, you just wait. No. That's great. So now you can go up higher and redefine CLS at the very beginning and then retrain it.
Right, so that we need less.
Yep. Yep.
Okay.
I'm just curious.
Wait, I'm not sure.
Yep.
Oh.
Perfect.
Okay.
So if you go up a little more, yep, right here. So evaluate this. Actually, don't even train it. Just no, you don't need to train it. So evaluate this. That's like reset CLF.
Yeah.
Random CLF. And then instead of hitting it to all guns, I like set it to the first country.
Yeah.
Magic because you have look at that.
Right.
So it's not quite as thick, surprisingly. Yep, so totally let the exercise. But then you can try other amounts of training.
Yeah. See where like the threshold is.
Yeah. There's a lot of in there.
Well, this is from before we talked about it. Hot data wasn't recorded.
I don't know.
That's evaluated all cells.
I'm not going to that. I mean, I did do
Sure. So
we just changed.
yeah, so to train on less instead of going minus 1. Let's say you want to train on just the first 2 values. Place minus 1 by 10.
Okay.
Now instead of going at thousands of values, you're going to only 10.
Okay.
Now you can go down to the bottom and run the same thing.
Well, you told me you were.
But it's still impressive. I got half of them right.
Yeah,
It's
that's
not 10.
why I was confused. I was like, why is it not returning?
It's like nothing. And now,
Is that not the correct one?
like by inputs, I mean values rather than 10.
Right.
Test it with a different number. It just basically is working on every single one. This training set is like everything. And then you can try if you go to the top, you create a CLF and train it with less data. And then it will
That's weird.
instead of training on every number, which is minus 1, you train it on like just the first 10 values. You just have to change the minus 1 to in both places.
Is there any like method to figuring out like
A lot of it trade-off.
I mean, I guess you could like maybe write. Yeah, you could.
And if you really built it about it.
In reality, when you're training something that's
Oh my God. Having pages is
just find as much data as possible.
quite smart.
So it's not
Yeah.
Yeah.
Right.
But if you like secure that grade.
there's like get more data and then you're trying to
Obviously,
all
you
of
know
it.
that.
Yeah.
So yeah.
Right now, I'm just like, oh, it's getting more. I'll increase it.
One of the cells above that did the training.
So it's kind of like do the actual work
Yeah.
somewhere else. It's a nice option. It's a just for us. What if you're like at like a you're on a trip? But you didn't get the option to.
Oh, okay. I'll try it. See what's up this. One. Oh, there's another problem here. The output of this is a 1-by-1 array, and this is a number. And so when you compare them, it always says they're false. But it's always
Nice.
so there's a difference. So you need to actually do like. See if the front end is back and zero.
Oh, yeah.
And then once you do that, you can delete CLF, or you can recreate CLF and train on the series. Yep, so it's not fitting. So all you have to do is one's higher, and where it fits CLF. Just re- just run off.
Okay, I might as well. I feel guilty now.
I
feel bad.
don't know if you read it.
One of them took forever. I think the second one took so long.
So the biggest part is that
The lots of fun.
yeah, so
I was.
So, for, let's see, may or may not, for C, I don't know, have you ever done
So with this area here, the bottom it just says it has a
hours?
So you just need to run.
Yeah, so I think it wants, or we're supposed to use the aggregate of a width from species categories. But okay, so I was
It's because you're working in the shared projects and so probably something else is research.
To like just the types, but I wasn't able to just like get each column. Yeah. So I like.
Okay, now I'm sure.
Yeah, that's what I just did.
Right. That's what basically I did that. And then so oh, so just say that so you can add any right. Yeah.
Actually, that's weird.
Call this something, and then just say oh,
But I don't know what the
right, yeah, yeah. I just yeah. So
I guess that's the way you do it.
I'll see that.
Yeah, that's fine.
Oh, do you want to do the H5? Oh, I did that right. You did it? Yeah, I just want to mirror file. Yeah, we don't care.
If you look, there's
Like, so, yeah. then
Group it together.
yeah. So we're gonna do 0 to like, it's going one less than the last one. Because learning everything but
So if I did maybe 50, I could do everything to the last one.
yeah. So or you can just say you can say you can do like the colon goes when you start and then
Actually, it seems like a.
Right. So I can say between.
yeah, you can say between 10 and 0.
Yeah.
Like so what I did is I just gave it
So give it 5 values. It's still pretty good. Actually,
it's easy to get into. I give it the first 5, it still has 6 more. Like you see we do like this, the colon and the 5.
this is how Facebook knows what I'm saying. This is what my it's close here. It's pretty dark.
Big note.
Don't come. It's Carson's really worried about it. He has this fear of Carson's fear. Everyone shows up 2 hours too. He's in he has to wait for everyone to go to yeah. Show up early and then like roll up and get the parts. No, we're not gonna. I'll say that one. Sunday, not Sunday night. Wait, we have Father's Day. Let's see. It's not like they're not gonna learn this. No, it's only one chance to try. But we're not gonna screw you.
No, they can. A lot more.
Have you seen that happen? If something happens in 45 minutes, that's true. That was rubber out, right? She threw him on the bar. That's true.
Like that's a lot.
Yeah.
Yeah, for city it was like just a little bit down. Yeah, and highway was like exactly the same. Yeah, yeah. I just want to make sure you did it right. Yeah, I was like expecting it to like be better. Right. I was like confused about there was even really different. Like what do you mean? It's like when I read the documentation, but I was confused like what it says. I'm just gonna like add some parameters, like index yeah, and like honestly, like I'm like it's like what like looking at it. I like looked at it and I was like that's like I feel like I keep it. Yeah, yeah. I had to like look at some of the values and like did like an average in my head, like okay, sure, it's fine for like how to just
correlation. And this, I don't know what the hell you call this.
You're just gonna take a small trip.
I don't even, maybe a straight line, maybe a straight line.
You like for what element we're seeing. You also have some interesting checks if your array is sorted. You're just iterating the cosmic arrays eventually. Yeah, mine's
The problem with this is it might be physics is sorting algorithms, including one with requires waits until cosmic rays for bits.
There's like a very small chance it will, but
Almost surely, as they say.
that is not what's fun. How's the schedule?
That's
the life cycle of the universe. Right, I think
You should have to actually read it.
Yeah, that's true. I got the stat from that. Yeah. Okay. So,
allows it to be a function of the surface area of your computer. Yeah.
The thing is, with like one line, using pivot tables, which you don't have to start.
Usually it's more like
That type PD dot pivot table is there's lots of
Usually modeling
there's type like one line.
per square meter every table that
I'm on the last one right now.
tall.
Which you
So
could
there's
do
one
on
volume of that.
Okay, so it's calculated.
And plus, like, it was
Probably also not so good.
Let's see,
It's like
I could be there.
Much better if you're high altitude.
very, very efficiently.
We'd have to
Huge
design a
table with
specific
lots of-
sheet.
It is all hard drive for you could
We'll
run.
take like every single row that's an audience, and put them all together in one single row. And then the other rows,
How about you?
or the other corresponding rows, so each single card.
See, the problem is
That'd be the best paper.
Fill it up with
you talk about a lot of very bad things we have.
Humans would eat
Yeah,
that
you
each other.
know, we're stuff.
Audi City,
I think the best part about it is
Audi Highway,
just the fact that you might end up in a sort of an array, but it's definitely. So really, that's a different problem. It's not sorting an array; it's returning a sorted array.
Well, you can have it check if it's the correct array.
It's in place. Yeah.
Maybe the
What do you mean by easier?
This is no, it's fine.
Is it acceptable?
Yeah, sure, if you like,
Yeah,
if you have the max,
yeah.
I don't see a single value. Which one is it? How do I know that? How do I know that?
you could
No, it has to
use
display,
different.
so you have to show the result. It has to be so-
You could somehow turn all the
Sure.
I'm going to load files from here onto your desk. I mean, from your desktop onto here. Oh,
The reason for that is that's the number of values in which you call them. That's the number of values. So these are numbers. There actually are dollar signs. These are just numbers that make sense if they're dollar signs. So I don't think that it's reading the data in a way that somehow is aware of monetary amounts. So
well, I uploaded the,
You could-
this is my CSV file.
change the CSV data so that they're not dollar signs anymore, or you could look to see if Canvas has some way of converting dollar sign stuff to not dollar signs. That would be very easy. It's a huge file. But you could remove every single dollar sign. Although I realize that's
That cost is really
I can show you how it's online in 400 dollar signs.
There's something.
So this one.
I actually still don't get
So
I actually still don't get the whole one. I got numbers for the last two problems, but I don't know where I'm running. There's code for it, but I just
Just.
well, okay, for the
every dollar sign.
for the problem that's we're gonna practice there is.
Yeah.
But for the other, but for the last two there isn't.
Open that pop-up.
So-
When CSV.
I forgot.
Open it for
I got two thousand 156.
Yeah, so now try that.
Which I do have something, but I had to go back and go back at it.
Yeah.
But it was they're not getting up to the restaurant.
Yep, exactly. Open directory. Yep. Yeah, and there's a command in Python called Python. Just show her just do it for Python. Open file name, comma, quotes W. You can write the string to take the right file to this really easily from within Python. There we go.
using not Windows.
It takes forever to shut down.
Is it just because you've used your computer for so long? It's old and crap.
So the reason for that is
How long have you had it? Like a year?
What, this computer? Not even close. Like, a month or two?
now there's a file name update. And you'll find your That's really, really easy to open and read and write files in Python. Just with this open.
I just want to know to you so I can easily ask a question.
Let's stop the screencast. Guess I figured out how to get the video to not break.